So today we are talking about pool allocators in C. Now pool allocators are quite a fundamental type of allocator, but they are extremely useful and you probably use them accidentally in your project already. So a pool allocator is quite simple in its idea. We have an array of objects, right? So here I've got an array of all these objects and they're the same type. So in the array they're consecutive, they're all the same type and same size. Now all a pool allocator is, it's an interface for us to allocate and deallocate these objects. And I'll show you guys what I mean by that in just a minute. But the important thing to know is, with the pool allocator, the allocator is a fixed size. So the actual buffer that we allocate things and deallocate things into is a fixed size. So we can't change it. Once we have created the pool allocator, that array it retrieves and puts elements back into, it's going to remain the same size forever, unless we create a new pool. So what do I mean by that and how does it look like? So let's say I've got this simple piece of code which has a pool allocator which you're creating using the function called createPool. We pass in the type of object we want in the pool allocator called obj, and you want 6 elements, right? So what that would effectively do is create an array of 6 elements which are all obj objects. Now let's say I want to allocate an object using the pool allocator. What's that going to do? Well, we're going to use this function called Pool Allocate, and it's going to take in the pool and return a pointer to an object inside of this array for us. So what we're going to do is just search through the array and find the first non-used element, or find the first element which has not been allocated before. So in this case, I represent the elements which have not been allocated before, or which are not allocated, as green. So obj1 is the first object which we can find, and that will be the value that we return from this function. So now obj points to obj1 in the array, which is the actual pool. Now let's say I allocate another object, then I call this obj2. So once again I search through the array in the pool and I find the next element which has not been allocated. In this case that's obj2. So there we go, obj2 is now taken and I return that from the function. What about freeing or deallocating things from the pool? Now to deallocate an element from the pool, we simply pass in, we have a function called poolFree, right? And we pass in the pool we want to return the element to, and we pass in a pointer to that element. Now it's important in this function to verify that this object is not a null pointer, and we have to make sure that this object actually maps to an object inside of the pool array, which is being stored inside of the data structure. So here obj points to obj1, so we just simply mark that object, so obj1, we just mark that as free to be allocated now. So it can be reused and reallocated again. Now, this system I just told you, where every single time you allocate or free something from the pool, we have to go through just when we're allocating things, we have to visit each and every single node in the pool until we've found a free object, right? So it's an iterative process. Now that's fine for small pools, but for big pools it can be quite slow, because if you imagine the first few iterations, it's fine, right? We just have to do 1, 2, 3 iterations to finally find a free object and we just return that. But if you've got hundreds upon hundreds of elements, or maybe even thousands, then we have to, as we allocate more and more objects, we have to search further and further into this pool to finally find a free one. And it doesn't scale linearly, right? So that makes it very slow for large pools. Now what's the alternative? Well, we can use something called a free list. Now a free list is just a linked list which keeps track of all the free objects inside of the pool. So these are all objects which we can allocate and we can give back to the user because they aren't being used. So how will this look like using a free list implementation? So here I've got a free list which has a linked list of all the free objects in the pool. So here I've got obj1, obj3, obj4, obj5 and obj6. So if I allocate a new object right here in the pool, all that we do is we find the first element in the free list. Actually, before we find the first element, we first check if the free list is empty. If it's empty, that means there's no more free elements left in the pool, and we can just return null straight away. So that's very quick and efficient, instead of having to search through the whole pool to find out if it's empty using the iterative approach. So here we just go to the first element inside the free list, which in this case is obj1, and we just return that, right? So now we just pop obj1 off the free list, and obj3 is now the new head of the free list, and we just mark obj1 as being used. Let's allocate another element, right? Once again, we go to the first element or the head of the free list, which in this case is obj3. We then free obj3 and we mark that one as red. So now we have 3 more elements left inside the free list: obj4, 5 and 6. What about freeing things from this pool? Well, we can have the pool free function, and all that will do is just take the element that the user's passed in, and you'll verify that it exists in the pool, right? And then we just append that to the end of the free list, right? It's super simple. You just allocations, take the head of the free list and take it out, and for deallocations you just append onto the end of the linked list. So it's super simple, and then I just marked obj2 as being free to allocate. Now I'm going to write down a basic implementation. So here I've just got a simple C program to print out hello world. I've just imported some libraries that we need to use. We don't need that. So the first thing I need to do is create some kind of structure to actually hold the pool allocator, right? So I'm going to do is create a struct called pool allocator, right? And that's going to contain a pointer to a bunch of blocks, which will be the type the user is going to provide. And this is just going to be the actual pool that we retrieve, and we mark elements as being used or unused, right? That's where the user can allocate things from. Then we're going to have a linked list of, it's going to call it free list, and this is just a linked list containing all the free elements inside the pool which are not being used. So I'm going to have a count just to keep track of how many elements we have in the pool. So I'll create a struct for the block, right? And let's just say this block will be the type we're going to, is like the fundamental type we're going to use for building this pool allocator, right? So what I'm going to do is just say that it's going to have a value, right? So I'm going to call this, let's say, int value. So this is the actual value we can store inside of this block. And then I'm just going to have a struct block pointer preview next, right? And this block pointer is just going to be what we're going to use to turn this free list into a linked list, so we can keep track of all the free blocks, right? Because this will just point to the next free block when we're doing that. Now if we want to, let's say, create a function such as pool allocator, I'll say pool equal to pool allocate, then pass in how many elements I want to allocate. So let's say 20, right? Actually, I'm not going to call this pool allocate, I'm going to call this pool initialized. And how are we going to do that? Well, I'm going to create a function called pool allocator. It's going to return that. Then pool initialize. It's going to return the pool allocator. Then just pass in the size, so the number of elements I want. So this pool allocator is going to be called pool is equal to dot pool equals malloc size of the block times by the size. And have a count as the size, right? Then I want to iteratively go through all of the blocks inside of the pool, and I want to do one by one, just allocate memory for them, right, using malloc. So, I'm sorry, not allocate memory for them, I want to initialize them. So I'm going to also set up the free list here as well. So say for int I is equal to 0, I is less than size I plus plus, right? I'm going to find this pool block right here. I'm going to initialize it. So say the value is going to be 0 for now. That's the initial value, right? And I say the next value is going to have is going to be no. And I'll explain why I have it as no in just a second. Then I'll say the next element is going to be no. And then if the free list is equal to no, then this will be the first element inside the free list. Otherwise, we have to traverse the whole linked list and then find where we can add the element. So what I've basically done right here is I've got this pool allocator, so I've got this pool object right here, right? and I just set the value it's going to have, right? So this value, I set that to be 0, and set the next element going to be null, right? Now I also did this for the next element. I set that to null, and what I've basically done here is I'm going to construct the free list right now. So if you think about it, when we're initializing a pool allocator, all of the elements inside the pool should be in the free list, right? Because none of them have been allocated, so they're all available to be used for allocations. So what I'm going to do is just first check if the free list is empty, because it will be equal to null then, right? Because I didn't mention it here, but at least in C, there should be a comma. Yeah. So in C, if I don't specify the free list right here, so if I don't specify it here, it automatically gets set to 0, which is going to be null in the syntax right here. So if this pool free list is null, that means that there's no elements in the free list. So this is the first element inside of the pool which you're iterating over. So I is equal to 0. So in that case, I'll just set the head of the free list equal to this current item. Otherwise, this means that we are in some middle parts, or maybe even the end of this pool, right? So what we have to do is navigate or iterate over all of the elements inside of the free list, find the end of the free list, and then append this element there. So how can we do that? We're just gonna create a pointer to a block object, say pool.freelist. So this points to the head of the free list, and I want to get to the last element inside of this free list. So I'll say, while the next element is not equal to null, set the blocks equal to the next element. So in this case, what we've basically done here is, let's say the free list is obj1, obj2, right? So what we're basically saying here is, if the free list is empty, then add obj1, the first element inside of this pool, into this, right? If it's not empty, then we're just going to navigate to the last element, which is not null, right? So this block value right here in this example will be equal to obj3, and then the current element we're trying to append, which is obj4, I'm going to append that at the end right here. So I'm going to do that. I'm just going to say obj3 in this example, its next value will be equal to the current block, which is going to be pool at I, right? And then I have to pass in a reference. This is an address, right? So we just added obj4 at the end. And then once you've done this, we can just simply return this pool right here. So what's about allocating stuff onto this pool? Well, that's pretty simple, right? We can do that pretty easily. All I have to do is create a function called Pool Allocate, right? So we've had to return a block pointer. So if I do Pool Allocate and then I pass in a pool, I can just check, okay, is the free list equal to null, which means that there's no values left in the pool, so the pool's been completely used. We can just return null, right? Because there's nothing left to return from the pool. Otherwise, we can just iterate over the pool again. So if we return the head of the pool, so we say pool free list, right? So if pool's free list is going to be equal to pool free list next, so I want you guys to imagine this. So if I have obj1, obj2, and then obj3 inside of this pool, let's add obj4, right? So I've got 4 objects inside of this free list. That's what I meant. So what this block currently is going to be the head of this free list, right? So obj1, and we know that there actually is a head, or rather at least one element inside of this free list, because we verified that free list is not equal to null. Because if it's equal to null, then we know that the free list is empty. So all we're doing is just saying, okay, make a temporary variable to store this block, which is going to be called block, and then set the free list equal to the next element from the head. So just saying that set obj2 as a new head of this free list. We're just getting rid of that reference to obj1. Now obj2 is the head of the free list. Now let's say we have obj1 and we only have one object in this free list, right? So how can we deal with that? Well, what's going to happen is obj1's next value, right? So obj1.next, that's going to be set equal to null, right? Because it's set equal to 0, it's set equal to null pointer. So when I do this thing right here, the specific line, pool free list is equal to pool free list next, what's going to happen is it's just going to set pool free list equal to null, because obj1's next is equal to null. So this test will then work by default. That's the pretty cool thing we can do. So how about deallocating things from the pool? How can we do that? So we can say pool deallocate. I could pass in a pointer to a pool allocator, right? Then I pass in a pointer to the block. The block I want to add back into the pool. So if this block to add is equal to null, so they pass in an invalid pointer, or with a null pointer, we just return right here. Otherwise, we could say that the block to add the next value is going to be set to null, right? Because we're going to append this onto the end of the free list. Now, if the free list is empty, then we can very easily just say, if it's empty, we'll just say that the head of the free list is equal to this block, right? Otherwise, what we can say is this block, we're going to have to iterate over the whole free list again to get to the end. And then setting that will say block to add. Right. So actually, instead of doing this, let's do. Okay. So if the free list is empty, this block to add will be the new head of the free list. Otherwise, we know that there are elements in the free list, so we're going to navigate through all of them, get to the end of the free list, and then we're going to add this element at the end, right? It's pretty simple. So let's see some examples of this thing in action, right? So if I do pool initialize 20 elements, then I'll say, okay, block first is equal to pool allocate pool, right? So then I can say first dot value will be 200. So let's print out this value. That should be a reference rather than a pointer. Okay, so we got 200, right? That's great. So let's say what should happen is I should only be able to, actually let's do this. Let's make this pool have 3 elements. Theoretically, right, if I implemented this right, I should only be able to retrieve 3 elements from the pool, and then it should return null because there's only 3 elements in the pool, so the free list should be empty. So if we can test this by saying, okay, printf if first equals null, printf is null, right? Actually, else. So let's do this 4 times, right? Okay, so what I've basically done here is I've created 4 I'll try to allocate 4 objects from the pool, and then I print out if the object returned is a valid object or if it's a null pointer. Now if I did this right, what should happen is I should get contains valid object 3 times, because these first 3 allocations should go through successfully because you have 3 elements in the pool, right? But this 4th allocation should return null because the free list should be empty, right? So we have 3 valid objects and then we get null back. That's correct. Now let's say I do pool 3, I'm gonna pass in the 3rd object, right? I always have to pass in a reference to the pool. Now if I try to get an element, we should have 1 more element inside of the free list. So now if we try this again, I'll call this block Deallocate. I'll call this pool 3, right? Okay, so there we go. It returns a valid object, so now the pool should be empty. So if I try allocating once again, just to make sure this really works. 6th, right? I should get null here because the pool is empty, right? So here we had 3 elements, so which we allocated successfully. We returned 1 element, so we were able to allocate another one, but then the pool was empty again, or the free list was empty, so then we got null. If you guys want to see how this looks like visually, I'll quickly show you guys. So we can open up the RAD debugger, then I should be able to show you guys how this all looks like. So I'll add a breakpoint for the pool right here. So let's run this. Hopefully you guys can see this. So it's running the program now, so I can just pass in the pool right here. And right now it's pretty much empty, but if I start walking through it, right, so we have this free list and it has 3 elements. So we have next, and then 3 elements, right? So pass in that, now you have 2, pass another one, we have 1 element left, but we got the last element out, so we try to allocate again, we get null. Then I return an element using pool 3, that gets added back to the free list, then allocate again. I try allocating again, no. Now you may be asking, okay, this is pretty cool, but how can I deal with multiple types? Because right now we're just passing in an integer, right? We can only set an integer value. What if I want to use strings, floats, doubles, or my own custom objects? Do I have to create a separate implementation of this structure for each and every single one? The answer is yes, that is probably the option you would have to do. And if we're in like a modern language like C++ or Rust, you can use generics or templates to solve this issue, but we don't have that in C in the same way. But what we can do is just use some of the C language features to emulate this generic property. So what do I mean by that? Well, if I create a union, I can have multiple types. Right, so I have an int value, I can have a float val, I can have a double val, I can also have a string value, right? And then I have to also keep track of what the block type is, and then I have to actually create a block type, right? So what did I do right here? Well, in C we have this concept of a union. Now, union is a special keyword, and what that basically means is this member variable in the struct can be one of these 4 things. It can be one of them. So what that means is the compiler will allocate enough memory for the largest of these types. So in this case, that will be a char pointer, which is 8 bytes, and to be honest, a double is the same size as 8 bytes, but the formatted differently. So that means is that this member right here will take up 8 bytes of memory. However, it can be one of these 4, and it will be decided when we try to reference it, right? So I can do something like I don't know, let's say this, I've got a block pointer. I did something like pool allocate, I got this object, right? So I have to make sure that I select one of these values and be consistent with it. So if I say, okay, I'm gonna use an int value, I'm gonna store an integer here, fine. What I can't do is afterwards go like, okay, I want to store a float value in here, I'll do 300. No. Well, you can do this. I can store an integer here, but then if I try to print it as a string, it won't work, right? So let's do something like that. So if I treat it as an integer, that means it's going to be stored, those 8 bytes of memory is going to use 4 of those bytes to store that 32-bit integer. If I try to then read it or treat it as a string, it won't work because it's formatted it as a integer. So you have to select a type and be consistent with it. Okay, but you can also do something like, okay, I stored an integer there first, but now I want to store a float, so I do something like that, and then I can just print out the float value. That's perfectly fine. Whatever value you've selected, just be consistent with it and make sure you're being careful with how you use it, because if you try to store, let's say you store an integer in there, but then you try to read in a string or you try to read in a double, you're going to have issues. It's not going to be the way you expect it to be. Okay, so this is how we can store different types, and we can also have this variable right here to keep track of what type we intend to use in this pool allocator. And then when we're initializing the pool, we just tell it, okay, well, what type do you want to have right here? And then I'll also have, I'll just say, when we allocate this whole pool, then I set the type to be equal to the type the user provided to. Right, so it's pretty simple. So now I can I'll just delete this quickly. So let's say I want to store in a double, right? So make 3 doubles. Then I can do first double val is equal to 500.3. Let's say, then just print that out. Oh, I'm supposed to say enum right here. Okay, we printed that, fine. Let's say I want to store a string in here instead, so I'll just say string. Oh. You don't actually need to pass in a type here, just to make it a bit more convenient for us to know what type we intend to have there. So I'll say hello world. Just print out this, and we get hello world. So this is just how we can store different types and how we can actually implement a very basic pool allocator in C. So I hope you guys enjoyed this video. I made previous videos about arenas, so if you're interested in how we can create custom allocators in C, I would highly recommend that you guys check out the arenas video. And something cool about this is we can actually construct a pool allocator on top of an arena. So you can use the functionality of arena to store all the things that we need, all the objects for the pool, and then we can just create this pool allocator as a layer on top. And I'll leave that as an exercise for you guys to try it on your own. It's pretty fun and interesting. And as always, I'll leave the code for this video in the description below. I hope you guys enjoyed the video, and I'll see you guys later. Bye.